All right, we're starting our 2 o'clock talks here. I want to thank everyone for coming to the second talk in G. Herbert Stout Student Awards. This is the second student from North Carolina Central University. This is our undergraduate representative, Cambria White, talking about identifying sources of methane leakage north of Salt Lake City as part of her internship at the University of Utah last summer.
Thank you for the introduction. Hi, everyone. My name is Cambria White, and I'm a senior at North Carolina Central University. And I'll be talking about methane leakage north of Salt Lake City today. So, why is methane leakage important to know about? Methane is a large contributor to global warming. It's a very potent greenhouse gas. It's even more potent than CO2, which is what we usually talk about when we're talking about climate change. And while there's less of methane in the atmosphere than there is CO2, it's still an area of concern that we want to take into account for future purposes. So methane is also a contributor to ground level ozone, which can cause respiratory issues over time and can aggravate people with asthma. And there are also indirect effects on crop yields, production, and human health. So we know about some of the common sources for methane. I'm pretty sure you guys saw the picture of the cows that I had on my title screen. So that's a major producer of methane if we're talking about natural production. But there's methane also comes from wetlands, which is basically the soil microbes in the wetlands. They emit methane. And then also from freshwater bodies. Oceans, it's a pretty small source, only about 1% to 3% of methane emissions. And then also termites, which I didn't know, which is pretty interesting. And then anthropogenically, we get methane from landfills, which is just waste just sitting in the landfill. And then also human waste can emit methane. And then the natural gas and petroleum industries are kind of the largest contributors for the anthropogenic sources. And in Utah specifically, there's a valley, which I'll talk about a little bit later, called the Uinta Valley and the Uinta region. And throughout that whole region, there are pipelines, oil wells. You'll see these big campers just sitting there, just collecting oil. So it's really big. It's a really big issue in Utah. That's kind of why we're talking about it today. There's a little chart for you too if you want to look at the methane emissions percentages. So over the years, there's been increases in methane, and this is similar with CO2, just as humans are becoming more advanced ever since the Industrial Revolution, from car pollution, and then in the case of methane, we're seeing a lot more commercialization of farms, which is leading to more manure. It's just sitting around emitting methane. And then also there's a higher demand for natural gas and oil, so that's also increasing the emissions. And something that's interesting is that during COVID, when emissions like nitrogen oxides and CO2 decreased, methane actually increased because the nitrogen oxides, they affect the sinks for methane in the atmosphere. So since there wasn't a lot of car pollution, methane was actually increasing and staying around in the atmosphere longer. So that's something I found pretty cool. And this is the focus area for the study, this is Davis County, Utah. The primary area of focus is going to be Bountiful and a little bit south of Bountiful, but the weather stations that we used for wind measurements and temperature and a few more atmospheric things were pretty much spread out all over Davis County. And what initially prompted the study to kind of locate methane sources in this region, there was a Methane Air Flyover, which is basically it uses an airplane that has sensors on it, And through remote sensing, we get these images, and we saw there was a spike in this particular area. We were like, what caused that? So that's kind of what prompted the whole study. And they do these flyovers sometimes twice a year, but definitely once a year. Here's some more perspective on the area. So this is a very heavy industrial area that is north of Salt Lake City. If you drive on the interstate, you'll see lots of these towers, and Chevron is a major company that's out there. I think BP is also out there, and a few other major brands that you've heard about before. And then there's also a residential area with older homes, and I'd note that it's older homes because they're more likely to leak fuels if they're using oil for heat and things like that. And then there's also a pretty significant wetland that's in this area because the Great Salt Lake is not so much of a lake anymore. There are some parts where it's deep, but it's kind of drying up, and most of it now is wetland or dried up. So yeah, it's kind of a little overview of the area. And then the main goal was to, of course, identify the main source of the methane plume, which is the highlighted red areas that we saw on this slide. So that was the main goal here. And to do that, we wanted to run meteorological simulations to model wind direction and speed. And what this would tell us is how the plume traveled over time. Did it pretty much stay in one place? Did it move to the east, to the west? Because then we could identify the source from that information. So we also obtained wind measurements from local weather stations to compare with model-generated wind speed and wind direction. And then we also ran a stilt trajectory model to look at how the plume traveled and kind of conditions for that day and how air was moving essentially. So first we collected wind measurements from local station data. We used 23 stations all throughout Davis County. And we looked at the measurements that were collected for August 11th at around 12 or 1 p.m., which is when the flyover occurred, so that we could best accurately figure out what the wind was at the exact time of the flyover. And then we also modeled wind direction and speed using WRF. And WRF is you can use it with Python to basically pull out U and V wind components, and you can calculate wind speed and wind direction from that. And then I plotted them all over. And WRF enables you to find wind direction and speed or temperature, anything else really, over a wider area and beyond the station data that we had. And then we wanted to compare how the model, the model to the station data to see if there was any overlap and if we could rely on the model for wind direction and wind speed, because the model would later be entered into the trajectory model, which would tell us about direction and things like that. So we wanted to make sure we could use the model, because if the model wasn't that accurate, it wouldn't really be significant to look at the trajectory. So we ended up finding that the model was pretty accurate. You can see that it overestimated the predicted wind speed, and it slightly overestimated predicted temperature, but it's still following a common trend. So we found that it was accurate enough to be used or to be put into the trajectory model. So this is the analysis and the stilt footprint. So since the model was accurate enough to use, we inputted that into this stilt trajectory model, which was developed by one of my advisors at the University of Utah. His name is John Lynn. And this is what the footprint came back with. And as you can see, the yellow is sort of where the concentrated pollutant in air is and how it's kind of moving south. And I've sort of highlighted in orange the some major oil and natural gas plants that are in the area, and you can see that it pretty much lines up. So we were able to determine who the culprit was, essentially. And also, I'm going to go back one more slide, or a few more slides too. I did mention that the wind speeds were very, very low, and the wind direction was variable, which means it was moving east, north, west, south. Like, it wasn't really staying in a constant direction. So we were able to determine that the wind wasn't a major factor in determining where the plume ended up. So we figured out that the plume was likely very local to the source, like where it came from. So, like I just said, meteorological analysis suggests that winds didn't really play a factor in moving the plume anywhere, so we knew that it was stagnant. And given the trajectory model and where it looked like it was coming from, it kind of lines up with the oil and natural gas plants. So we figured that is likely the source. There has been another flyover since this project where they're gonna essentially do this analysis again and see if it lines up that way. So this is not 100% final, but this is kind of like a preliminary thing that we found out. And just to give some more information about the Uinta Basin history that I was kind of mentioning earlier, the Uinta Basin is located in northeastern Utah, which is pretty much east of Salt Lake City. And it's a very dry area. It's a pretty drastic difference. But like I said, there are the oil and gas industry is huge out there, and it began in the 1900s and is still like very prominent. And it's an issue of concern because Salt Lake City and surrounding areas, it's a growing region, so it's important to know about potential methane leakage, and also it's important for the state and the city to be meeting its goals in terms of keeping the emissions low. And let's see, and then the methane leakage, it comes with the transportation of methane. So if it's being transported in pipelines underground, the storage of methane, and of course the processing of these fuels, and then the burning of the fuels in homes. So these are my acknowledgements. This research was a part of the REALM program that I was a part of last summer, which stands for Research in Alpine Meteorology. And I worked with the LAIR group, which is the Land Atmosphere Interactions Research Group. And thank you, everybody, for listening. I'll take questions.
Any questions for Cambria?
Yes.
What is the height of the windows in there?
The height? I believe it was 10 kilometer, or maybe 10 meters. Yeah, sorry about that. The height of the plane. I'm not sure about that. Yeah, sorry about that.
You showed that pie chart earlier, and it showed a big chunk of the methane leakage, the biggest due to these kind of industrial leakage.
Mm-hmm, right.
And the agricultural industry, did that fit? I was just curious.
Oh, yeah, that would be the manure management. I think that's where it would probably fit in.
Okay,
Yeah.
So 9%. Okay, sorry.
Mm-hmm.
I just wanted to, because I know there's been a lot about the talk in the news of the methane
Yeah.
released from cows, but in actual fact, this natural gas and petroleum, that's a big chunk of it.
It is, yeah.
Wow.
Yes.
What would be an example of enteric fermentation?
Oh, enteric fermentation.
Is that maybe the wetlands?
Yeah, I would think that would have something to do with the wetlands or the fresh water bodies. And I know I'm not sure about the enteric part, but in terms of fermentation, the warming of the climate is leading to like faster rates of fermentation and decay, which is creating more emissions. So it's kind of like a never-ending cycle of, yeah.
And we don't hear much about that in the news, too.
Yeah, you don't. It's, yeah.
But that's also quite a large portion.
Another question.
Oh, yes.
Speaking of that, is there, and maybe this is, I guess, part of figuring out, is this kind of, like, how do you separate some of this, like, natural, like, wetland versus, natural gas or petroleum?
Mhm.
I guess was this project kind of a process of trying to separate that out? and figure
Honestly,
out-
it was. So the person I mentioned that created the stilt model, John Lynn, he was like very passionate about that, about believing that the plume was because of the wetlands. And we were kind of thinking that initially, but it was like the wetlands and the natural gas petroleum, they're so close to each other. So that's why we want to continue like doing a similar analysis when we get more like flyover data and remote sensing like scans. But no, I think wetlands, it's definitely going to play a factor. And I think like repeating this similar process will hopefully determine like which one is affecting it more, but they're probably both affecting it a pretty substantial amount. So, but no, yeah, wetlands are definitely of interest. Yeah. Yes.
What's the resolution of the flyover data?
Resolution. I'm not exactly sure of that either. Sorry about that.
In that map of those hot spots, what's the highest concentration? I didn't really clearly figure out. Yeah. Those red spots, what's the typical high concentration?
Number-wise, I can't give you an exact number.
Yeah, I have a small handheld.
Oh, okay.
Since we walk around everywhere,
Mm-hmm.
even though supposedly it's 1 ppm, which is 1,000 ppb here, we wouldn't really see anything.
Yeah.
Zero
Mm-hmm.
all the time.
Yeah. Yeah, this area I wouldn't expect to see much.
But I mean, if we could take it there.
Oh yeah, it would
we
probably
might
be
able to
really
see.
high. Yeah. Yeah.
Okay, thank you very much.
Thank you, everybody.